We are going to talk about Pythagoras theorem and how can we benefit from it in triangles. So first of all, how can we benefit from Pythagoras theorem? We can use it only in right triangles in order to determine missing lengths in a right triangle when we have two other lengths. So we should have given two other lengths and then we can find the third one, the third side of a triangle using Pythagoras theorem. And this is the formula. A squared plus B squared equal C squared. And you can see on the figure where is A, where is B, where is C. C is the hypotenuse, okay, which is the longest side, and A and B are the two other sides. So the hypotenuse is always the longest side in a triangle, and it can be found the side that is opposite to a right angle. So this is the right angle. The side facing the right angle, it's the hypotenuse. A and B are the other two sides. A small example on Pythagoras theorem, we are going to find the length of the side BC. So as given, we have two sides that we know their measures. AB is equal to 6 centimeter and AC is equal to 10 centimeter. This triangle is a right triangle as we see. Then we can apply Pythagoras theorem. Then Pythagoras theorem says that the longest side, which is the hypotenuse, is equal the hypotenuse square is equal to the sum of the other two sides also squared. So we say that ABC is a right triangle, then by Pythagoras theorem, AB squared plus BC squared equals AC squared. We substitute each side by its value. AB squared is 6 squared plus x squared equal 10 squared. We do the math. 6 squared 36 plus x squared equal 100. We move 36 to the other side in order to have x squared alone on this side of this equation. Then x squared equals 10 minus 36, x squared equals 64. But be careful, we haven't finished yet because we now get x squared, but we need x. In order to remove the square, okay, what removes the square is the radical. So we put radical both sides. X squared becomes x and 64, it's radical 64. Now, how much is radical 64? 64, it's 8 square, and the square removes the radical, then the answer is 8. So BC, which is x, it's 8 centimeter. Another quick example, also the same question. We have to find x. Now x is the hypotenuse in this case. So in the right triangle, okay, of course it's a right triangle in order to apply Pythagoras theorem. Hypotenuse square, which is AC square, is equal to the sum of the sides, the other sides. So AB square plus BC square equals AC square. We substitute each side by its value. Now this one, the BC is 2 radical 5 squared. So the square is for both 2 and radical 5. So 2 square is 4 and radical 5, the radical and the square, they cancel each other. Then the answer is 5 equals x squared. Then x squared is equals to 7. We move it as it is. And 4 times 5 is 20. Then x squared is 27. Then x equal radical 27. Now, how do we solve radical 27? We do prime factorization and we divide by the prime numbers. The first prime number is 2, but 27 is not divisible by 2. Then we divide it by the second prime number, which is 3. We do the prime factorization. The answer will be 3 cube. Now, x is equals to, I didn't write it 3 cube, I wrote it 3 square times 3. Why? I divide it, yani the first two together, and then I keep the 3 alone. Because when we have a number squared, it is cancelled with the radical. So 3 square, the square is cancelled with the radical. So هاي اللي 3 بتطلع لبرا. And the other one is radical 3. It keeps the same. So the answer is 3 radical 3. Now, converse of Pythagoras theorem, we use it to prove that a triangle is right triangle. So when we are asked to prove that a triangle is right, we use converse of Pythagoras theorem. So if we were able to prove that a square plus b square is equal to c square, then the triangle is right. For example, we have this triangle ABC. We have all the measures, but we don't know if this triangle is right. We don't know. Okay, so what do? We solve both sides of the equation. The first side is the sum of the two sides, and the second one is the hypotenuse square. So AC square plus CB square, we solve it. The answer is 25, and the hypotenuse square is 25. Since they are equal, then this triangle is right. Now we can apply Pythagoras theorem in right isosceles triangle because it's a right triangle. So by Pythagoras theorem, AB square plus BC square equals AC square. But in a right isosceles triangle, the two sides are equal. So this is A and this is also A, the measure of it. And A is a general number. Then but I don't know the hypotenuse, what is the measure of it. So I put instead of AB square, A square plus A square equals AC square. A square and A square, I can add them. So AC square is equals to A square, I added them. Then, in order to find AC, I put radical both sides. AC equals radical 2A square. The square is cancelled with the radical, then AC is equals to A radical 2. So AC is the hypotenuse is equals to A radical 2. This is a general rule. We can use it always without proving it. Also, we can apply Pythagoras theorem in semi-equilateral triangles. So, semi-equilateral triangle, it's the triangle that is divided in two. Okay. First of all, we need to find the measure of the small side, which is the side facing the 30-degree angle, this side here. So we know that in an equilateral triangle, all of the sides are equal. This is A, and this is also A. And when we say semi-equilateral triangles, means it's an equilateral triangle that it has been cutted in to two parts. Then this big A side, it's cut into two sides. Then the measure of this side, this small side, will be A over 2. So we know now two sides, then we can apply Pythagoras theorem in order to know the measure of the remaining side. So as a general rule, the side facing the 30-degree angle, it's equals to A over 2. Always we can prove it without using it. This is the 30-degree, yani the small angle. It has a small angle and it has a bigger one and a 90-degree. So only facing 30, it will be A over 2. So after we have known the measure of the side facing 30, which is A over 2, and we know that the hypotenuse is A, so now it's time to know the measure of the side facing the 60-degree angle, which is AB. This triangle is right. We can apply Pythagoras theorem, and we apply it. We substitute each side by its value. BC square, it's A over 2, and AC square is A. We distribute the power A square over 4 لأنه وزعنا الباور 2 على A وعلى 2. We take it to the other side and we make only same denominator because this one is over 1 and we cannot substitute two fractions without having same denominator, so we multiply by 4 in the numerator and by 4 in the denominator. The answer is 4a square over 4. Then we can subtract them. 4 minus a square, it's 1a square. So 4 minus 1a square, the answer will be 3a square over 4. But this is b square, so we want ab square. We want ab, not ab square. We apply radical on both sides. a square, a it's squared, then the square cancels the radical for a only, and 4 it's 2 square, so also we can cancel the square for 2, then a over 2 radical 3. So therefore the side facing 60 is a over 2 radical 3. It's a general rule, we can use it without proving it.